Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning, everyone. Today we will explore ecosystem resilience and how biodiversity and human activities combine to change, whether ecosystems persist in their current state or shift to a very different regime. When ecologists use the term resilience, they refer to the capacity of an ecosystem to absorb disturbance and reorganize while undergoing change so as to retain essentially the same functions and structure. One useful way to think about resilience is to consider two properties biodiversity provides: redundancy and response diversity. Redundancy means that several species perform similar functional roles, so loss of one species may be compensated by another. Response diversity refers to differences among species that perform similar roles in how they respond to disturbance. If all species respond the same way to a stressor, the system lacks insurance against change. Let me give you a concrete case study. The kelp forest system in the North Pacific provides an excellent example. In healthy kelp forests, sea otters prey on sea urchins, keeping urchin populations in check. When otters were hunted to near extinction in some areas, urchin numbers exploded and kelp forests collapsed. This case shows a keystone species effect. A keystone species has a disproportionately large influence on ecosystem structure relative to its abundance. When a keystone species like the sea otter is removed, the entire system can shift rapidly as sea urchins proliferate and kelp forests collapse. Contrast that with soil microbial communities, where many species perform similar roles in decomposition. There, the loss of a single microbial species often has little immediate effect because other microbes can compensate. The system is more buffered. But buffering has limits. Ecosystems have thresholds. When pressures like habitat destruction, nutrient loading, or climate change push the system past a threshold, a regime shift can occur, and returning to the original state can be difficult or impossible without major intervention. Consider the Chesapeake Bay as another example. Excess nutrients from agricultural runoff and urban sources fuel algal blooms. When algae die, they sink and decompose, consuming oxygen that leads to hypoxia or dead zones where fish and shellfish cannot survive. Management responses in Chesapeake Bay have included nutrient reduction strategies and restoring oyster populations that filter water. These are attempts to change the drivers and enhance ecosystem services. Such actions demonstrate applied restoration ecology. We also see success in Costa Rica, where payment for ecosystem services programs incentivize landowners to restore forest cover. Those policies increased reforestation, enhanced carbon sequestration, and benefited biodiversity. They show how economic instruments can align human behavior with ecological resilience. Climate change adds another layer of complexity. Warming alters species ranges, phenology, and disturbance regimes. For instance, coral reefs experience bleaching when water temperatures exceed normal seasonal maxima. Repeated bleaching undermines recovery and leads to reef degradation. Given limited resources, conservation strategies must be prioritized. Sometimes focusing on keystone species or critical habitats provides the greatest return for maintaining ecosystem function. Other times, broad-based approaches like reducing nutrient inputs or establishing connected habitat networks are better. Finally, I want to emphasize monitoring and adaptive management. Resilience is not static. Managers need to monitor indicators such as species composition, nutrient levels, and recovery rates. Then, policies can be adjusted as new information appears. In summary, resilient ecosystems depend on biodiversity, the distribution of functional roles, and the magnitude of human pressures. Practical conservation combines species-level interventions, landscape planning, and policy tools to keep systems from crossing harmful thresholds.
Listen again to part of the lecture, then answer the question.
When a keystone species like the sea otter is removed, the entire system can shift rapidly as sea urchins proliferate and kelp forests collapse.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.